Hello everyone, so in this video we are going to solve a question of LeetCode, that is reverse linked list 2. So let's start with the problem statement. Given the head of a secret linked list and two integers left and right, where left is less than equal to right. Reverse the nodes of the list from position left to position right and return the reverse list. Right. So basically in this question we have given a linked list and two positions, that is left one and right one, and for this position we need to reverse the linked list. Right, we need to reverse the linked list from left position to the right position and return the reverse linked list. Right, so let's see the first example. So in the first example we have 1, then we have 2, right, then we have 3, then we have 4, then we have 5. So basically we have given 5 nodes here, right? So for these 5 nodes, what we need to do is, let's say we have given L is equal to, that is the left one is equal to 2 and right is equal to 4, right? So we need to reverse this from the left position to right position, right? This we need to do. So let's see, we are just need to reverse this part here, right? So let's quickly see how can we perform this reverse operation here, right? So to perform this reverse operation we will be using some pointers, right? So we can easily reduce the time complexity as well as space complexity by this approach. That's why we are using pointers here, right? Because these are the constant pointers. So let's do this. So for these pointers, let's say we need to return the linked list, right? We need to return the reverse linked list. So there might be the possibility that this first node will also be reversed. So there might be the new node here, right? So in this condition we need some reverse memory or the temporary memory which will be keeping a point at the first node, right? We need something. So for this we will be placing a dummy node here, right? So let's say we kept a dummy node as 0 here to keep this, to keep any of the node, or we can say any of the next node of the dummy node as the head of the linked list, right? So whenever we will be returning a linked list from here, we will be returning the dummy next, right? Because dummy next will always be containing the head of the node, right? It will always be pointing to the head of the linked list, right? After reversing or performing all the operations, right, this might go somewhere some other position, but the head of the linked list of the reverse linked list will always be pointing to the dummy next, right? So let's see, we have kept a dummy node here, right? So this is the first step. We have kept the dummy node and pointed this dummy node to the head of the linked list, right? So this is the first step. Now let's see the second step. Now the second step is we need to reverse this part, right? We need to reverse this part. So to reverse this part we are keeping two pointers here, right? So since we need to reverse this from 2, so let's say we kept a current pointer here, right? Let's say we kept a current pointer here. All right, this is current pointer, and the second pointer also we need to take is the previous one. Previous is basically the previous point from the current one, right? Because this previous will always be fixed here, right? Previous will always be fixed here and current will always be fixed, right? These two will be fixed, and we will be taking a temporary pointer to manipulate the value, because we need to shift this 3 and 4 in between of this 1 and 2, right? We need to shift this somehow in between of 1 and 2 because we need to reverse the string from 2 to 3. So this 2 will go to end of the substring and this 3 and 4 will come before 2, right? So let's see how we are doing this, right? So till now we have kept this previous and current pointer. Now you must be wondering how we kept this pointer, right? Here we have just placed, but how can we do it logically, right? So there is a very simple logic for this, right? There is a very simple logic. Since this is the second node from the original linked list, but in this case we have taken a extra node, right? So this is basically the L plus 1th node, right? This is the L plus 1th node. It means the previous one is the Lth node, right? It means the previous one is the Lth node. So what we can do, we can just do a iteration L times, right? Since it is a Lth node, so we can do L time iteration to point this previous node from the dummy node, right? Let's say we point the previous node to dummy node initially, and we will just iterate to previous next each time till L positions, right? So for this is the second position from the dummy node. So we kept previous here, and the previous next will always be the current one, right? Because the current before is always the previous, so previous next will always be the current, right? So till now we have kept this previous and current points, right? Now the next step and the very crucial step for this is we need to reverse this part, right? We need to reverse this part somehow. So let's see how can we reverse this part. Right, so there is a very simple approach for this. So let's say we keep a temporary pointer here, right? Let's say we keep a temporary pointer here. So let me write the steps side by side, right? So let's take the first step is we kept a temporary pointer that will be equal to the current one, or we can say that will be equal to previous next, right? That will be equal to previous next, right? This is the first step we perform. Now the second step, let's see the second step. The second step is we need to point this previous next, right? We need to point this previous next to current next, right? Somehow. So what we can do is we can point this previous next. Let's say we write previous next is equal to current next, right? This is the second step. Now, why we have done this? Because we are just performing the iterations, right? We are just performing the iteration. And how many times we are performing? We are just performing this L minus, or we can say R minus L times, because we are just performing this R minus L times because we are currently at this node and we have to perform this till here, right? So what is R? R is 4 and L is 2. So 4 minus 2 is equal to 2. So we need to perform this to the next two nodes from the C, right? From C we need to perform this two times, right? So we will performing this to R minus L times, right? So this is clear, I guess. So let's see the third step. So in the second step we just performed previous next to current next, right? And in the next iteration we might be changing this to 3 to 4, right? Or we can say previous next to 4 in the next iteration, but in this iteration we only need to do this 3, right? Because in the each iteration we will just point this 3 to 1, right? Then 1 to 4, right? These are the iterations going on, right? So let's see the third step. So we just change the previous next from here to here, current next, right? Now the next step, let's see, the next step is current next, right? Current next, this is current next, right? This is current next. Now this current next will be pointing to current next, right? This is current next and this is current next, right? So this will be pointing to current next, right? So this will be removed from here, right? This one will be removed from here, and this will be pointing to current, will be pointing to current next, right? So this will be current next is equal to current, this will be current next and next, right? This is current next. Alright, so these are the three steps, and the only remaining step is, right, the only remaining steps is you must be observing this is the this one, right? This is this one. So for this what we need to do is we need to point this 3 to 2, right? Because for by performing this reverse, this string will be reversed from 1 3 2 and 4, right? And in the next iteration this will reverse to 1 4 3 and 2, right? So that would be the reverse string. So for this what we can do is we can just point this is current next, or we can say this is basically the previous next, right? This is previous next, this is the previous next, and this is next. So this is previous next. So the fourth step would be previous next next, right, previous, next will be equal to temporary one, right, will be equal to temporary, right. So you must have observed that why we have kept this temporary, because the positions might have been changed. That's why we kept this temporary, so that we can easily point at the end, right. So we have just removed this from here. So the updated linked list would be 1, now this is 3, now this is 2, now this is 4, and now this is 5, right. And now in the next iteration we will just reverse the positions. So now this 4 will come here, and the updated or the final reverse linked list would be 1, 4, 3, 2, and 5, right. These steps will be iterating 2 times, right. So in the first iteration we will get this one, and the second iteration we will get this one, right. So I hope the approach is clear to you. If you still have any doubt in this approach, feel free to comment it down. I will try to explain it again. Let's move to the coding part. So in the coding part, let's first take the dummy pointer. So this is equal to list node dummy, right. And let's initialize the value. Let's say this is the dummy, right. We have taken this dummy, so dummy is equal to new list node 0, right. And also take two more pointers, the previous one and the current one, right. And the previous is initially pointing to dummy, right. We have already discussed this previous is pointing to dummy, and this previous will be updated till l times, right. So let's write the same here. Previous is initially pointing to dummy, and this one current will be empty, right. So now let's update the position of the previous one, right. So to update the position of the previous one, let's run the for loop for int I is equal to 0, I should be less than left, and I plus plus, right. And let's update the position. So previous is equal to previous next, right. So it will just move the previous till l minus 1th node, right. So let's see now, this current is always the previous next, right. So let's write the same here. This current is equal to previous next, right. I hope this is fine. So now let's write for int I is equal to 0, like we need to reverse the central part, right. This part from left to right, right, this part from left to right. So for this, let's run the for loop from 0 to r minus l, right, r minus l. So let's write the same here. I is equal to 0, I should be less than right minus left, and I plus plus, right. Now let's write these four statements here, right. We are just writing as it is. So let me write it here. Let's write list node temporary is equal to previous next, right. And this, what are these condition? This is previous next is equal to current, right. We just move this previous next to current. So let's write the same here. Previous next is equal to current next, and this current next is equal to current next, and at the end we did previous next is equal to this one, right, temporary one, right. We have just already discussed all the four statements in the explanation part, right. So at the end just return dummy next, right. We already discussed why we are returning dummy next, right, because dummy next will always be containing the head of the reverse linked list, right. So let's now quickly submit this, or try to run this on the sample test cases. Oops, we are getting an error here. Let me check. Hmm, this is not finding the previous null point. Yeah, we forget to point the dummy next to head because this this dummy node is initially pointing to the head of the linked list. Then only we can traverse the previous pointer till the other position, right? So this should be dummy next equal to head, right? And also let's check it again. Yeah, they should be left minus 1 because we are just iterating till left minus 1, right? This is the left one, so this should be left minus 1, right? So I hope this should work fine. Now let's try to run this again. Yes, working fine. So let's start to submit this. Yeah, it's working fine. So the time complexity we already discussed is big O of n because we are traversing through all the n nodes only once, and space complexity is big O of 1, that is constant because we are not using any extra space here. Alright, so that is it for this video. I hope the approach and solution is clear to you. If you still have any doubt in this question, feel free to comment it down. Please like this video and subscribe to our channel. I will see you in the next video.